We're told here that our particle is under the influence of three different forces, and we're told that the particle is in equilibrium. In other words, the forces acting to the right and right should equal the forces acting to the left. Forces acting upwards should equal the forces acting downwards. So first of all, I'm going to find Q by using the fact that the forces acting right equal forces acting left. So the 4 Newton force acting to the right must equal the component of Q acting to the left. In other words, Q cos 20 degrees. Q then is just going to be 4 divided by cos 20, and that comes out as 4.26 newtons. If we now do the same in an up-down direction, acting downwards we have P, and acting upwards we're going to have the component of Q in an upward direction. Well, that's Q. This angle here is going to be 70 degrees, so it's going to be Q cos 70 degrees. Now, if you use the exact value from Q that you've just calculated, that was actually 4.256 originally, multiply that by cos 70 degrees, you end up with P, and P comes out as 1.46 newtons. What the question now asks you to do is to work out what's going to happen if you remove the 4 Newton force. Now, what we've got to realize here is that because the particle is originally in equilibrium, the whole system is equivalent to having a P Newton force acting downwards, and there must be an equivalent force acting upwards, and a 4 Newton force acting to the right, and again there must be an equivalent force acting to the left. In other words, Q here is exactly the same as a component of P acting upwards and 4 newtons acting to the left. If you now remove this 4 Newton force, you can see that there's going to be no up or down movement because the forces acting upwards and downwards are exactly the same, and the particle is then going to move to the left under the influence of only that 4 Newton force. In other words, it's going to move in the opposite direction to the original 4 Newton force.